Think about the last time you walked past a sprawling industrial plant.
Oh, yeah, like a massive refinery or something.
Exactly. Or really any massive piece of civilization-level infrastructure. You see thousands of people, heavy machinery, volatile materials, and, well, an environment that's entirely exposed to unpredictable weather.
Right. It looks like absolute chaos to any rational observer.
It really does. So
Yeah.
how do we guarantee that a liquefied natural gas facility won't just, fail, or that a suspension bridge won't collapse under its own weight? You can't just throw steel and concrete at a site and hope for the best.
You certainly do not. I mean, behind all that orchestrated mayhem, the VUD, the diesel engines, the sparks, there is this invisible, ironclad framework holding it all together.
Yeah.
It's basically an intricate web of accountability that dictates, every single move made on that site.
And today we're exploring the exact anatomy of that framework. Okay, let's unpack this. For today's custom deep dive, we are looking at a highly technical foundational piece of source material. It's a document dated today, June 5, 2026, and it's titled CMC SPUK 001, Specification for Site Quality Assurance Quality Control Requirements.
That's a mouthful.
It is, yeah.
Yeah.
But basically, this specific text serves as the ground rules for contractors operating under a FIDIC Red Book construction contract, specifically the 2017 edition.
Right, and if you work in complex infrastructure, the mere mention of the FEIC Red Book carries serious weight.
Oh, absolutely.
The 2017 edition in particular is globally recognized because it fundamentally shifted how risk is allocated, and how disputes are avoided on these mega projects.
It demands an incredibly rigorous approach to quality management.
Exactly. Reading a specification like this isn't just about understanding construction. It's about, understanding the philosophy of proving exactly how you built something, down to the molecular level.
Wow. Yeah, so we are going to distill this blueprint so you can see the mechanics of that accountability, but we aren't just going to walk through this document like a boring table of content.
No, nobody wants that.
Right. We want to understand the tension between the people building the structure and the people paying for it. So let's start with the initiation phase. Before a contractor can even bring like a backhoe onto the site, they're bound by the Quality Assurance Plan, or Q.A.P.
Q.A.P., yeah.
According to the document, the contractor has exactly 15 days from the contract award, or before site works begin, on a supply and erect contract, to present this customized plan to the employer.
Which is a remarkably aggressive timeline.
Wait, really? 15 days doesn't sound too bad.
Oh, 15 days is an absolute sprint when you consider the sheer volume of empirical data and organizational logic required. The Q.A.P. is not just some broad mission statement about a commitment to quality.
Right, it's not a marketing brochure.
No, it is an exhaustive operational matrix.
Yeah, looking at the appendices of the specification, the Q.A.P. requires a highly detailed site organization chart. Like, you have to clearly define who holds specific authority for quality control. You have to lay out your entire system for material control and traceability. The document even explicitly singles out the need to provide standard certifications for specialized roles up front.
Right, specifically the welders, the NDT non-destructive testing inspectors, and HT, or high-tension electricians.
Well, we know why those specific roles are so heavily scrutinized, right?
Oh, definitely.
Yeah.
In high-tension electrical systems or high-pressure vessels, a microscopic flaw is literally all it takes to initiate a catastrophic failure.
Just a tiny mistake.
Yeah. The people conducting the non-destructive testing are the last line of defense before a flaw becomes a disaster. So the Q.A.P. forces the contractor to verify that every single technician holds valid, current certifications before they ever step foot in the mud.
It's essentially a cryptographic handshake before a data transfer, but applied to physical engineering.
That's a great way to put it.
You're establishing the precise parameters of trust before the system goes live. Like a meticulously detailed recipe you have to get approved before you're even allowed to turn on the oven. But, I have to challenge the practicality of this. A multi-100-page quality assurance plan is ultimately just paper.
Right.
It lives in a pristine binder in an air-conditioned site office. So if you're a site manager facing brutal weather delays and massive financial penalties for missing deadlines, how does the employer actually force you to honor that paper plan when you're out in the mud?
Well, that is the eternal tension in construction, isn't it? The pressure of the schedule versus the mandate of quality.
Yeah.
What's fascinating here is the mechanism this specification uses to enforce the Q.A.P. in the field. It uses a concept called hold points.
Hold points.
Right. When the contractor submits their Q.A.P., they're required to define these hold points throughout their construction sequence. A hold point is a pre-agreed, non-negotiable moment in the process where work physically ceases.
Ceases entirely. But wait, if you're managing a massive concrete pour for a foundation, you might have like dozens of cement mixers idling and a huge crew on the clock.
Oh, absolutely.
If every major step requires you to literally drop tools and wait for an employer supervisor to arrive, doesn't that bleed money? How do you maintain flow on a critical path if you're constantly enforcing these hard stops?
It absolutely causes friction.
Yeah.
And yes, it costs time in the micro sense. But you have to weigh that against the macro timeline.
Okay, what do you mean by that?
Well, imagine pouring 10,000 tons of concrete over a grid of steel rebar without an inspection.
Oh boy.
Yeah. Once that concrete cures, the rebar is entombed. If you discover later that the steel was tied in correctly, or maybe the spacing was off to accommodate a later pipe run, you don't just have a scheduling delay.
You have to demolish the foundation.
Exactly. You have to rip it all out.
So the hold point is an enforced bottleneck designed to prevent asymmetric risks.
Precisely. At a hold point, the contractor and the employer supervisor must physically walk the site together. They inspect the rebar against the drawings. Only when both parties are entirely satisfied do they sign the quality record form.
So it's a shared responsibility.
Yes, a synchronous dual signature responsibility.
Mm-hmm.
And the document strictly dictates that while the contractor keeps the original signature, they have to immediately provide a photocopy to the employer to build a duplicate, secure set.
Wow, okay. So if something goes wrong later, no one can claim they weren't informed.
Nobody can play dumb.
Right. But that brings up a crucial pivot, I think. The Q.A.P. establishes the ideal. The hold points attempt to enforce the ideal. But reality is messy.
Very messy.
Materials arrive damaged. A subterranean rock formation forces you to shift a structural pillar. Human beings just make calculation errors. When reality violently clashes with the paper plan, how does this specific contract handle it?
Well, it addresses it through nonconformance management. And the FIDI 2017 framework is particularly interesting here.
Oh.
Yeah, the specification allows contractors to use their own internal tracking systems for minor day-to-day issues. However, it mandates that any significant nonconformances must be entered directly into the employer's master system.
The employer's system.
Yes, a shared database covering all operations by all parties on the site.
So what does this all mean? I look at that requirement and I see a massive disincentive.
How so?
Well, in a highly litigious environment, if you're a contractor and you make a significant error, voluntarily logging that mistake into the employer's master system feels like handing them a loaded gun to sue you with later.
It does, yeah.
Human nature basically dictates that you quietly fix the error before the boss notices.
It goes entirely against human instinct, yes. But in civilization-level infrastructure, burying a deviation is treated as a far more severe offense than the deviation itself.
Because the stakes are so high.
Exactly. The specification enforces a cultural shift. It treats nonconformances not as moral failures, but as inevitable engineering realities that require transparent joint resolution. If you hide a structural deviation to protect your pride or your wallet, you jeopardize the entire facility. The transparency is mandatory because the shared master system ensures the problem is engineered out properly rather than covered up quickly.
Wow. It's fascinating because you're essentially criminalizing the cover-up rather than the crime.
That's exactly it.
And speaking of reality forcing your hand, let's look at how the physical blueprints are handled in the field. The document addresses drawings on site. We all know contractors work off plans marked approved for construction, right?
Right.
But the specification requires the contractor to maintain 2 specific sets of prints on site at all times, and they must mark up any modifications in red ink on a continuous, ongoing basis.
Red ink mandate. It's a perfect illustration of empirical engineering.
How do you mean?
Well, an approved for construction drawing is, at its core, a highly educated hypothesis.
That's the theory.
Exactly. An engineering firm theorized how a complex web of electrical conduits, structural steel, and HVAC ducting would all integrate. But when you're actually standing out in the mud, you might find that shifting a foundation pillar by 3 inches, due to that rock formation you mentioned earlier, creates a cascading physical conflict.
The domino effect. So if the pillar moves, the plumbing has to move, which means the ductwork now intersects with a cable tray.
Exactly. So the blueprints are the hypothesis. The red ink is the empirical data. The specification strictly requires that these deviations be marked up with the employer's prior agreement and, crucially, on an ongoing basis.
So you can't just do it at the end?
No. You do not wait until the project wraps up 12 months later to try and reverse engineer your memory of where you moved a pipe. You track the living, breathing evolution of the structure in real time in glaring red ink.
It really shifts your perspective on what red ink means. I mean, in school, red ink means failure. On a mega project, red ink is the signature of reality.
Absolutely.
But this brings us to the ultimate question of enforcement. We have the 15-day Q.A.P. sprint, we have the dual signature hold points, we have the transparent logging of nonconformances, and the real-time red ink.
All great systems.
Right. But if you are the employer financing a multi-billion-dollar build, how do you verify that the contractor is actually doing this and not just sitting in a trailer at 5 o'clock on a Friday, fabricating forms and scribbling red lines from memory?
You utilize the audit clause. The specification grants the employer the right to conduct a comprehensive quality audit of the contractor's entire system. And get this, they only need to give 5 working days notice to trigger it.
Wait, 5 days? If your documentation is a disorganized mess, 5 days is nowhere near enough time to fabricate a coherent paper trail for a massive industrial site.
It's totally impossible.
Yeah.
And the document further tightens the leash by stating that this 5-day notice can be reduced if an urgent quality issue necessitates an immediate, targeted investigation.
So they can just drop in.
Yes. When the employer conducts this audit, they are systematically comparing the reality of the site against that very first Q.A.P. submitted at the start of the project. And the outcomes of these audits aren't just suggestions.
They have teeth.
Serious teeth. The conclusions dictate corrective actions tied to hard, non-negotiable completion dates. It applies a constant, unyielding pressure on the contractor to maintain the integrity of their data.
Which leads us directly to the handover, the grand finale of the project. Here's where it gets really interesting. The physical asset is complete, but as we are learning, the physical asset is almost meaningless without the informational asset that validates it.
You can't have one without the other.
Exactly. The document dedicates a massive section, including Appendix B, to what is known as the construction dossier. It's like the project's permanent autobiography.
The construction dossier is the absolute culmination of everything we've discussed. It is the definitive proof of execution. Appendix B lays out a rigidly standardized format.
Yeah, I saw that.
This dossier must be presented at the time of acceptance in physical A4 binders. Furthermore, it must be delivered in 2 complete iterations. Set O, which holds all the original wet ink documents, and Set C, which contains the authenticated copies.
2 complete sets of A4 binders. And you cannot deviate from the structure. There are 9 standardized chapters. The specification notes that even if a chapter is entirely inapplicable to a contractor's specific scope of work, they must still include the chapter divider and formally declare not applicable.
Yeah, that standardization is vital for the life cycle of the facility. It guarantees that an auditor or a future engineer can pull a binder from any contractor working on any subsystem and instantly know how to navigate the data.
To really understand why the employer is so obsessive about these A4 binders, we need to picture the nightmare scenario.
Okay.
Let's look at the actual contents of the dossier. Chapter 2 demands the purchase materials records, unpriced suborders, and material certificates. Chapters 3 and 4 house the procedure and personnel qualification records.
Right, the welder certs.
Yeah, and Chapter 5 holds the quality records from all those hold points. Chapter 6 contains the resolved nonconformance reports, and Chapter 8 is the final engineering drawing markups.
If we connect this to the bigger picture, let's put those chapters to the test. Imagine it is 10 years in the future. The original contractors have long since demobilized.
They're gone.
Completely. The facility is operating at maximal capacity. Suddenly, deep inside the plant, a high-pressure steam valve begins vibrating violently.
Oh, man.
Yeah. The facility managers are facing an imminent catastrophic failure. They need to intervene immediately. But intervening blindly in a high-pressure environment is suicidal.
So they need a forensic backward trace.
Exactly. They run to the archives and pull the construction dossier. First, they pull Chapter 8. But they aren't looking at scribbled blueprints. The specification dictates that those red ink markups we talked about must be transformed into formal as-built drawings.
Ah, so they get formalized.
Yes. Each drawing must be physically stamped with the exact phrase. Certified with MODIF, as built without LODIF. Followed by the contractor's name, signature, and date. The facility managers look at that stamp drawing to see exactly how the piping around that valve was rerouted in reality. not how it was hypothesized 10 years ago.
Because if they cut into a wall based on the original theory, they might hit a high tension line that was moved during construction.
Precisely. Next, they pull Chapter 2 to examine the material certificates. They need to confirm the exact metallurgical composition of the steel used in that specific valve to understand its failure threshold.
Right.
Then, they open Chapter 4 to verify the certification of the specific welder who attached that valve to the main line, and Chapter 5 to see the ultrasonic testing sign-off from the hold point.
Wow. So within minutes, they have reconstructed the entire physical, material, and human history of a single failing component.
Without the construction dossier, those facility managers are flying blind. The physical structure is just the manifestation of the project. The A4 binders set O and set C are the true asset.
The real deliverable.
Yeah, they are the DNA of the facility, allowing future generations to operate, maintain, and eventually decommission the plant safely.
It fundamentally changes how you look at a skyline. A mega project doesn't succeed through sheer engineering muscle or brute force. It survives through the relentless standardized tracking of data.
Exactly.
It starts with the 15-day sprint to establish the parameters of trust in the Q.A.P. It relies on the deliberate friction of hold points to prevent buried mistakes. It demands the uncomfortable transparency of logging nonconformances and the humility of tracking empirical reality in red ink.
Well said.
And it all culminates in that final 9-chapter autobiography, the construction dossier, proving beyond a shadow of a doubt that the reality matches the rhetoric.
It is a remarkable testament to human coordination. And I want to leave you, our listener, with a final thought to ponder. This specification we've analyzed today treats quality not as a subjective feeling, and certainly not as a mere aesthetic outcome. It treats quality as a continuous, auditable chain of evidence. If you are forced to create a construction dossier for your own most critical projects right now, whether that is a massive initiative you're leading at work, a business you are scaling, or, a complex personal system you're building, what would it look like?
Ooh, that's a good question.
Have you established your own non-negotiable hold points where you physically stop to verify the integrity of your foundation? Do you have the as-built red markups that prove how you adapted to empirical reality? Or are you just pouring the concrete as fast as you can and hoping the final structure holds up under pressure?
That is the ultimate metric for accountability. If you don't have the paper trail to prove your foundation is sound, you aren't engineering. You are just crossing your fingers. Thank you for joining us on this custom deep dive into the invisible frameworks that keep our world standing. Keep observing the mechanisms around you, keep demanding empirical proof, and as always, keep questioning the blueprints of your own world. We'll catch you next time.
See the link in the description for free PDF download. Also, watch our other construction scope videos. Thanks for watching. Please subscribe and see you next time.